Hello, my name is Danny Beard, and this is my presentation on my VX5002 Compositing for Visual Effects Pro module here at Escape. The project brief for this module is as follows. You are required to submit a final composite of your CG live shot with some rig removal tasks using your CG assets and the chosen live background plate from the VX5001 3D Visual Effects Pro module. You must utilize several compositing techniques in the shot. The shot length should be about 80 to 150 frames depending on its difficulty. You must use rig removal cleanup techniques and incorporate color correction processes to seamlessly integrate your patches. This needs to include 2D point tracking and 3D nuke projections. You must composite multiple render passes of CG elements into the VFX shot by balancing the render passes and integrating them seamlessly into the background plate. All work must be carried out in Nuke without going back into Maya to edit the CG. This is my initial ideas that I created for my Gotham scene. These are my CG assets layer contact sheets which show the different AOVs that I rendered from Maya. All films are made up of red, green and blue channels. Using an Alpha Explorer node network in Nuke, I was able to visualize these channels in a 3D space. Upon importing my CG backpod into Nuke, I noticed that it had no alpha. Alphas are essential for masking and integrating elements onto a backplate. To create an alpha, I used my crypto map pass and a copy node to copy its attributes. I followed this with a pre-molt to give my CG asset a usable alpha. Due to the natural shape of camera lenses, raw film is deformed, causing subjects to appear differently to their actual shape. In the 3D VFX Pro module, I exported my undistorted plate as well as a nuke node which I would use in this nuke script. To make my CG and all of my projections properly integrated, I undistorted them with this node and then reapplied the original backplate distortion to them before merging. The main goal of this project is to effectively integrate my CG from the 3D VFX Pro module, and I did this by rebuilding my rendered passes in Nuke. When working in Maya, I made sure to export my render layers with appropriate AOVs. These are all contained within the final EXR files. To extract the passes, I used several shuffle nodes and created a vertical merge spline so that I could edit them separately. Using shuffle nodes to access the AOVs gives you much more control when it comes to grading and changing the appearance of your CG. My indirect and direct background elements and my headlights pass were added in separate backdrops and then merged into my main spine. To improve integration of my CG object onto the backplate, I use vector blurs and defocus nodes to resemble the focal length of the original camera. Using my depth pass, I could manually place the focal point of my defocus. This is very effective when it comes to matching the blurriness of the backplate. Using light, relight and position to points nodes, I was able to project my object in Nuke's 3D space. The position to points node takes the position pass to determine the location of components in my CG model. This point cloud is very useful for getting accurate projection placements and when aligning the reconcile 3D axis. Camera tracking is essential for adding cleanups and projections to a shot. Using Nuke's automatic 3D camera tracker, I distributed over 2,000 points in which the software calculated the movement of the camera. I also experimented using the Create Mesh from Points tool so that I could see my point cloud as a physical object. I ultimately decided on just using cards as they are more reliable than this method. To achieve a more aesthetically pleasing shot, I used RotoPaint nodes to cover several signs and litter found in the backplate. I did this by using the clone tool to sample clean areas and then paint them over the top of the unwanted objects. I then set these clones to appear on all frames and then projected them on a card with an appropriate roto. This is my node workflow for my cleanup. In each instance, the roto paint is painted onto the undistorted plate and then distorted before merging with the backplate. To make my rotos less visible, I made sure to add blur nodes before copying the alpha channel into the roto paint. The constant that is plugged into the scanline render is set with my original backplate dimensions so that my cards project at the correct resolution. One of my major scene changes is the cleanup of the bin and the rubbish on the right hand side of the shot. This was achieved by using multiple roto paints at different frames and projected images that I created for the new wall. These are some images that I sourced and created in Photoshop for my projections. Projections involve taking the environment point cloud generated by the camera tracker and aligning cards with the desired scenery. These cards are then used as a canvas in which you can display images and roto paints. Following my initial concept, I projected several images of signs and graffiti. A flaw that I noticed in my script is that I use scanline render nodes for each individual projection. While this method works, for performance it is much more efficient to use one scanline renderer and connect all of the projections through a scene node. To achieve a more seamless integration of my new wall projection, I added a subtle shadow to the bottom half where it connects with the floor. This was done by grading the green channel with an invert applied to the alpha so that I could make a dark gradient at the base of the image. This was then graded on top of the projection and pre-molted to make it visible. Color grading is an essential process in which the colors of a shot are manipulated to either convey story or to improve integration. I had to grade all 9 of my projections so that they conveyed the same aesthetic as the original backplate. This involves using color wheels, waveforms, and sliders found in the grade node. When adjusting the gamma of the projections, I had to compensate with a saturation node so that they could maintain their original color. The most important object I had to color grade was my CG object. This was a very tedious but rewarding process. Thanks to my AOVs contained within the EXR, I had so much control over how it looked and could grade the passes individually. My backplate has dominant blue and green colors, so I ensured that my CG blended in with this color palette. Using a crypto matte mask, I graded the tires to look more worn, as well as changing the diffuse direct's white point to accentuate my substance painter textures. 2D tracking allows you to determine the precise location of distinct features in a scene. This can be then used to stabilize footage, clean up, or project. I conducted a test by tracking a selection of pixels in the corners of this white sign. Once I had 4 well-tracked points, it allows you to create a corner pin. The traffic light colored dots indicate the best and worst areas of the track. To add more story to my scene, I also wanted to add the bloody handprints to the window. I did this using the 2D tracking method opposed to rotoring a card in 3D. The white dots represent the edges of my corner pin, as it effectively tracks the movement of the window in the scene. These experimentation slides show work that I would have loved to include in my final piece, but had to be cut due to either not looking right or insufficient time. Using my background indirect pass from my Maya render, I rotoscoped the puddle so that the reflections were only visible in the water. As seen in my initial ideas concept, I originally wanted to create a dead end in the alleyway in which Batman's shadow would be projected on the wall. After color grading and adding grain to my Photoshop wall panel, I had a lot of trouble finding a sufficient place for the walls to connect. With this wall going between 2 completely different buildings, it didn't look aesthetically pleasing having such a sharp cutoff between them. Noise can be used to create an endless amount of effects that change the mood of a shot. To see how my shot looked if it had thick fog covering the lens, I made this effect by distorting and animating a noise pattern. Using God rays and a 3D reconcile node, I was able to amplify the projection of my headlights to give the illusion of volume. After experimenting with different techniques to achieve this, I decided against the cone-shaped look as I believe it detracted from the final look of the shot. Here is my original backplate that I use for integration. And here is my final composited render of my CG and added elements onto the backplate. This module has given me a much greater insight into how to effectively integrate a CG asset onto a backplate. It has put to test my skills of organization and improved understanding of several of Nuke's most valuable nodes. I feel that if I dedicated my time to one main element, I could have achieved a better final aesthetic. An unfortunate consequence of spending a lot of time on my projections meant that I could not achieve my desired outcomes for the volumetric headlights and CG reflections. Ultimately, I've completed the project brief as well as adding extra elements to my scene to make my CG feel as if it belongs. With extended work in Nuke, I believe that I will be able to become much more efficient in the software and hopefully work my way towards becoming a 3D generalist. Thank you for listening.